Okay, so what we have is our two vectors, and then to help us out, just to kind of get a little understanding, I wrote our two vectors in a component form, right? I took away the I and j, so we can just kind of see what they look like in vector form. And I'm going to keep them in this format, just so we can remember, if I wanted to find the vector of this, if I want to do u minus v, remember, all we simply need to do, if I was going to kind of forget about I and j and just write this in component form, remember the vector in component form, all it is your v1, or sorry, your u1 minus your v2, and then your u2 minus your v2. So I do 1 minus 2, comma, 1 minus a negative 3. Right? Remember, subtraction is v1 minus u1 minus v2, and then u2 minus v2. So in this format, what we'll have is 1 minus 2 is going to be negative 1, comma, 4. Okay, that's going to be u minus v in our component form. You could have done the exact same thing with the i's. Just subtract them. You'd notice that if you did u minus v, you could also just simply write this as negative I plus 4j. You could even do this in your head, right? The minus and the adding. All I'm simply doing is subtracting these two, your i's, and then subtracting your j's. Right? Cool? Questions? No?
Yeah. Wait, what is that? U minus v equals negative I plus 4j?
I wrote them in their component form. And then all I'm simply doing is subtracting the u1 minus v1, u2 minus v2. That's just the other way of doing it with the i's and the j's if I use it as a linear combination. It's the exact same thing.
You can do either one.
I'm just writing it as this component form so you guys can see it a little bit differently. But component form and linear combination is the exact same thing. That's what I've been spending time early in the day making sure you guys understand that they're the same. So now let's go and look at vector resultant. Let's go and look at the resultant vector for this. All right? So now we know that our resultant vector is negative 1, 4. So we can plot that as negative 1 up 4. 1, 2, 3, 4. Okay? But let's go ahead and see now, how does this even make sense, right? How could we write this if I was just given my two vectors and I wanted to figure out what the resultant was? So let's plot u and v. So if I was going to plot u, we know that u is at 1, 1, right? Okay, that's u. And we know that v is at 2, comma, negative 3. 1, 2, negative 3. 1, 2, 3. Okay? So ladies and gentlemen, what we're going to do, if I want to figure out what the resultant vector is, rather than saying u minus v, I would like to do u plus negative v. Is that OK to do? Yeah. Yes, right? 3 minus 4 is the same thing as 3 plus negative 4, right? OK. Now, if we know if v looks like this, what does negative v look like? Well, it's just going to be a direct reflection, right? Yeah. So it'd be over 2 up 3. Right? If this is v, then that's negative v. Now, how do you do adding, right? You take one vector and put it on top of the other vector. So therefore, if here's negative v, if I do u plus negative v, so what I do now is I transpose my negative v to the end of my vector u, and guess what? You get it to the end of your resultant vector, right? Because this brown vector represents u minus v. OK? Any questions? No. OK.
So what are you looking for the answer? You're just looking
The brown.
Okay.
The brown is the answer. But I'm showing you all this red, how to get to it.
Okay.
OK? Because it says sketch it.